Hi everyone, so today I'm going to discuss about derivatives of exponential functions. So let's see about today's lesson. Especially on last lesson we learned how we can find the derivative of logarithmic function. So as considering the opposite side, now we are going to consider about exponential functions. First let's see what is exponential function. In 1330 course also you have learned about exponential functions. We call it as y is equal to e to the power x. So now we are going to find the derivative of this kind of functions. So this is the behavior of exponential function. It is sometimes we call it as growing functions. So according to given definition, this is the idea. If we take e to the power x as our original function, then derivative also is e to the power x. So it is very easy to memorize that. If we take the derivative of e to the power x, it is also e to the power x. So it is given in here. So this given formula is very important. Now let's look at few problems. So first one is y is given as 3 times e to the power x plus 11 plus 4x minus 11. So you need to find the derivative of this function y. Let's see it. So we have to think it by part. First we consider about this part. So if we consider about this part, 3 is a constant, so no need to worry about it. It remains as the same in here. And then take the derivative of e to the power x. So today we learned that the derivative of e to the power x is also e to the power x, so it doesn't change. Then we can write the derivative of this term. 3 times e to the power x is 3 times e to the power x. Now let's move this part. So if we consider in here 4 is a constant and x is a variable, so here also we are deriving this function with respect to x, so finally it becomes 4. And if you move to this one, negative 11, so you know it is a constant. If you derive this negative 11 by with respect to x, it becomes 0. So this is the final answer for this problem. And now I am going to consider about the kind of functions. Y is equal to e to the power u. The specialty in u is some function of x. So we can write u is equal to some function of x, or sometimes it may be t. So this is the derived formula if y is equal to e to the power u, where u is a differentiable function of x, then dy over dx is equal to e to the power u times du over dx. Let's see some examples how we can solve problems in this given formula. So our first one is y is given as e to the power ln x to the power 2. So we need to find the derivative of y in here. So now you can recognize that this is your u. So your u is this one. Ln x is x square. So now let's take the derivative of this given dy over dx. So use this formula. So now you can learn how we can do it. So e to the power u, so it remains as the same, e to the power ln x square. Now you need to take this derivative du over dx. So last day we learned that if you are given some logarithmic term as ln x square or something, how we can take the derivative. So first I take this is 1 over u, then 2 times x. So finally the result is this one. So this is some application problem of future value. Let's see about the problem. So first it is given that when $100 is invested at 8% compounded continuously, the amount that occurs for t years, which is called the future value, is given as of t is equal to 100 times e to the power 0.08t. At what rate is the money in this account growing? So you need to find the growth rate of this account at the end of first year and at the end of 10 years. So you know if you are given some function and they are asking increasing rate, what we need to do? So we need to find the derivative of this one. So first take the derivative of this given function. S of t is equal to 100 times e to the power 0.08t. So here also this is your u, 0.08t. So 100 is a constant, it remains as the same, no need to worry about this one. Then take the derivative of this one, e to the power u times, this is your du over dt. Du over dt term, this one. So you need to calculate this one. So this is your u. So 0.08t, if we derive this one with respect to t, it becomes 0.08. So now you need to calculate this given one. So after simplifying, you can get 0.08 times 100 is 8 and e to the power 0.08t. So in the problem it is asking at what rate is the money in this account growing at the end of first year. So you need to substitute 1 for this given t, because we need to find increasing rate after 1 year. And in part B it is asking at the end of 10 years. So what we need to do, we need to substitute 10 for this given derived function. So this is our final answer for the second problem. Now let's consider about derivative of y is equal to a to the power u. So specialty in here is, previously we discussed about the functions of the kind y is equal to e to the power u, and here this base is a. A may be any number, 1, 2, 4, 6.5, 7, anything. So let's see how we can derive such a function. So already they have given the derivative of such a function, dy over dx is equal to a to the power x ln u. Specialty in here is, if y is equal to a to the power x, this is the formula for such a derivative. And secondly, if y is equal to a to the power u, this is the derivative of such a kind of function, y is equal to a to the power u. So by looking at these things, let's try to solve some two problems. First one is, if y is equal to 4 to the power x, find dy over dx. So let's see about it. So here I have done it. This is our given problem, y is equal to 4 to the power x. So we learned that if y is equal to a to the power x, we can use this formula directly. So first we need to understand what is our a. So our a is equal to 4 in here. So only thing you need to do is substitute for this formula a as 4, then you can get the answer directly. Our second problem is y is equal to 5 to the power x square plus x. So in here we need to recognize that here x square, x is our u. So this is a kind of a to the power u problem, this kind. So we have to use this formula. So already we know a to the power u, so no need to worry about it. So our a is 5 in here. And our u, what is the value of u? It is x square plus x, and du over dx is 2x plus 1. Now we can substitute one by one. So a to the power u is this one, 5 to the power x square plus 1, and du over dx we already calculated, it is 2x plus 1, and ln a is ln 5. Okay, thank you everyone. Let's meet on next day from 11.3.